Good morning. We'll start session 2 on chapter real numbers. So the first part in real numbers what we studied was about Euclid's division lemma or algorithm. So the second sector or part what we studied today is about fundamental theorem of arithmetic. So to understand fundamental theorem of arithmetic, we need to first understand few basic concepts which you have already studied, and it's a known thing, that is prime numbers, composite numbers and factors. So let's see the definition. Prime numbers, a number is called a prime number if it has no factors other than 1 and the number itself. So 2, 5, 7, 11, are some prime numbers. To note that 2 is the only even prime number. Rest all prime numbers when we talk about they are odd. Composite numbers. A number is called a composite number if it has at least one factor other than 1 and the number itself. In simple way, the numbers which are not prime are composite. So which it could be 4, 6, 8, 24, etc. So these all are composite numbers. When we talk about prime and composite, something what we saw there was 1 did not even occur in prime nor in composite. That is, 1 is neither prime nor composite, but 1 is a factor of every number. We always get confused when I ask list prime numbers. You start from 1, 2, 3, 5, 7, so and so on, right? But that's a mistake. 1 will not come in prime numbers nor composite. 1 is neither prime nor composite. It is a factor of every number. So factor of a number. If a number divides another number exactly without leaving any remainder, then the number which divides is called the factor of that number that has been divided. For example, if I want to write factors of 24, 1, 2, 3, 6, 12, also children, 24 are the factors of 24. That means 1 is a factor of every number and the number itself is a factor of that. So the lowest factor is 1 and the highest factor is the number itself. I think we have all done this in our 4th, 5th, 6th standard. Write the factors of so and so numbers, right? It's again a basic concept which we are just recapitulating it. I want you to keep a heading as fundamental theorem of arithmetic and just write down these points. So few more concepts and with the definition of fundamental theorem of arithmetic. So every composite number can be written as a product of prime, and this can be written as a product of primes. That is, for example, if I have a number say 6, how do I write 6? It can be written as 2 into 3 as the product of prime. Every composite number can be expressed or can be written as a product of primes, and this factorization is unique apart from the order in which the prime factor occurs. This complete concept or the factorization is unique in the sense it can be only represented in this and this manner only, apart from the order how we write the prime factors. That's a definition, children. What you understand here, 6 can be written as 2 into 3 or 3 into 2, that's unique. That is what we are mentioning this in the form of a definition. This is the definition for fundamental theorem of arithmetic. Next, basic concepts to understand what actually is HCF and LCM. HCF is the highest common factor of 2 or more numbers, is the largest number that divides all the given number exactly. Means HCF is the largest number that divides the given number, which is also called as greatest common divisor, GCD, right? You might have done this, find HCF or GCD of a given number. LCM, least common multiple of 2 or more numbers, is the smallest number which is divisible by all the given numbers. So suppose if I give you say 8 and 12, or okay, suppose if I give you 8 and 16. So here HCF is what? Of course, HCF when I try to find here, for 8 we get that as 2 into 2 into 2. So factors of this I want to write. 2 2s are 4, 4 2s are 8, 8 2s are 16. So HCF is of course 8. LCM is 16, right? Read the question. Two or more numbers is the largest number that divides the given number exactly. It divides the given number exactly, right? It divides the given number exactly. Then LCM of two or more number is the smallest number which is divisible by the given number. That is what the main concept you have to understand here is. Now apart from this, we have one more concept in this chapter about relationship between HCF and LCM. So relationship between HCF and LCM. Okay. Now what is this relationship between HCF and LCM? Suppose if A and, okay, we'll take capital A and capital B are two numbers, then we can say that A into B is equal to HCF of A into, HCF of AB into LCM of AB. Remember this relation, children, which we are going to use it here. A into B, that means if I find the product of two numbers, this product of A and B is always equal to the HCF of AB, what number I have got, and LCM of AB. If I multiply this and multiply this, it is equal. LHS is equal to RHS. So next few more definitions what you have to write down is fundamental theorem of arithmetic, HCF, LCM, relationship between HCF and LCM. So with this, we'll immediately start with the next exercise. So we'll quickly start with an exercise. It's a very simple exercise, children. Express each of the numbers as a product of prime factors. We know how to do that. So I'll choose just two sums here. Remaining you can practice it. So first third one, 3, 8, 2, 5. I will start with this. Now here when we talk about prime factorization, we are not going to do it like this. Rather, because in your book what we suggest is we have to do that by factor tree method. Now what is this factor tree method? You all have done this factor tree method. So 3, 8, 2, 5. It is a number. It can be expressed as the product of 5 ones are 5 sevens are 35, then 5 6 are 30, 5 5s are 25, right? This is factor tree method. Then further again, take the factors of 765. Again 5s are 5 1s are 5, then 5 5s are 25, 5 3s are 15. Now 153 we have. So 5 6 7 8 9 divisible by 3. So 3 5s are 15, 3 1s are 51. So 3 1s are 3, 3 7s are 21. Further you cannot do anything here. So how do we write? 3 8 2 5 can be written as, write all the prime factors only, children. Do not write the numbers which you get the splitting part here. So numbers are, sorry, we'll start with 5. 5, only factors they have asked. 5 into 5 into 3 into 3 into 17. These are the factors. Can also be written as 5 square into 3 square into 17. Right? This is how you represent the factors. I'll do one more, children, that is 7429. I'll do it here, which is fifth one. 7429. So the remaining first one, second one, fourth one, you can make it that for practice. So 7429, the factors what I will start here is, yes. Now the thing here is 7429. Check. Divisibility by 2 not possible. Divisibility by 3, is it possible? No, it is not possible by 3. Okay, now we have 9. So how to check the numbers whether it is can multiply with that numbers? Then what we do is, since it is 9, 7 sevens are 49. There is possibility it can go by 7. So we can check with 7 first. If by 7 it is not possible, what is our next go? 11? No, it is not happening with 11 also. So what we will do if 7 is not possible, our next possible is 13. Why? Because 13 threes are, we have again something 9 there. That's how we check the divisibility number. 13 also is not possible here, children. So what we have to do next? Our next is 17. Is it possible by 17? Yes, possible by 17. If in case you think that this was not possible by 17 also, what should be your next number? 23. If not, 27. That's how we go with trial and error method. Okay. So we'll check this with 17. So 17 fours are, 3s are, and 17 sevens are. Then again here we have 7 in the ending part. This number is quite complicated. You again start checking with the type of the numbers where in the particular tables we have 7 in the ending part. So quite big number it is. So sometimes you have to practice such big numbers to solve it. So this when you multiply, children, you get 1923s. Yeah, I know it is difficult, but you can get such difficult numbers, but one or the other number you would have practiced in one or the other books, right? When you see my assignment question bank what is given to you, you have list of such numbers given, you have worked examples, solve it, one or the other sums, you will understand. Finally, 7, 4, 2, 9 factors are 17 into 19 into 23. That's all. This is prime factorization of the given numbers. So quickly we'll move to the next part. Find the LCM and HCF. Both together we have to find in the given number. Yes, one more thing, children. I keep getting calls, messages, students asking me that, teacher, this is deleted from my syllabus. In my school, they have told this is not there, that exercise is not there. So what should we do? One thing you keep in mind, I will be teaching everything what is given in the textbook, right? Why? Because later what is told in your school, you can follow it and do it. But here in my classes, I will be solving all the chapters, all the exercises, even optional exercises also. So that is what I wanted to make it very clear. Everything I know, because you might be wondering sometimes, oh, teacher might be not aware, she's not aware, so she's teaching me. No. Well in advance, well before you all know that the content was selected, I have already got the information that what content is there and what content is not there, but still I am teaching everything what is there in your book. So let's quickly start with the second main. Find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equal to product of two numbers. That verification we have to do. I'll choose one sum, children, here again. Second one. First and last you can take it for homework. 510 and 92. So let's find the factors of 5, 10 and 92 by prime factorization method. So 5, 10 when we talk about, so we'll start this by 5. So 5 ones are 5, 5 2s are 10, you do not write because two numbers at a time we are taking. So 5 2s are. So 102 when we have, we can again write this as 2 5s are 10, 2 ones are. Then we have 3 1s are 3, 3 17s are. Similarly, 92 when you write, you start with 2, 2 4s are 8, 2 6s are 12, 2 2s are 4, 2 3s are 6. 5 10 is equal to 5 into 2 into 3 into 17. 92 factors are 2 into 2 into 23. So first of all, let us see that what are the common numbers here. Now, when you have to find the HCF, you have to first find the common factors. Now, common factors here is 2, right? So only 2 is the only common factor here. So HCF is 2. Now, LCM I teach you two methods of doing. First of all, using this only we can find LCM. How? See again. First, what we have to do is for LCM, write what is common in both. What is common? 2 is common, right? Write it off. Then, write what are not common and remaining terms in remaining factors of 5, 10 and 92. What are they? They are 5 into 3 into 17 into 2 into 23. These are all the remaining terms in the given factors. So when you find the product, that's going to be a bit large number, children. You have to sit, multiply them. So you will get that as 23,460. So yes, this is your LCM. 23,460. Now let me teach you one more method to find LCM. That's up to you if you want to find it. So this is 5, 10 and 92. This we know how we find it, right? So we go on writing the numbers. That way also you can find. So we start with 2 if you start. So 2 2s are, yeah, we'll start with 2 or we'll start with 5. Okay, we'll start with 2. 2 2s are 4. Then 2 5s are 10. 2 5s are 10. 2 4s are 8. 2 6s are 12. When you go on continuing that, you get the numbers and you get the same factors at last. I'll not be doing it, but did you understand? This is our old technique method, finding LCM. Either you can do that or anyways you have the factors here. First write the common factor, then write the remaining terms. Okay, so our work is done here. We found HCF, we found LCM. Next they have told verify. Verification. Let A be 510 and B be as 92. We know that A into B is equal to HCF into LCM. What is A into B? A is 510 into 92. That is equal to, what is HCF, children? HCF is 2. What is LCM? LCM is 23460. Check. When you multiply 510 into 92, you will get the number as 46920. That is what you get when you multiply this 46920. Teacher, what if you get wrong? If you get wrong, either your HCF is wrong or your LCM is wrong. That's all, right? So this verification always goes correct. It's product of given two numbers is equal to the HCF and LCM of the given numbers. So there we finished the second main. Quickly we'll go with the third main. Find LCM and HCF of the following integers by applying prime factorization method. 3 numbers are given. Now let's see how to find HCF and LCM for 3 different numbers given. Again, we'll do that by prime factorization only. So since the chapter is, since the exercise is very simple about HCF and LCM, that's why I'm just choosing one sum. So remaining you can practice. Remaining you can take that for practice. Third main, find the LCM and HCF of, I'll be doing first one, children, that is 12, 15 and 21. So what you can do is, remaining 2 you can take that as for practicing. First we'll write the factors for 12. 2 6 are, 2 3s are. 15, 5 3s are. 21, 7 3s are. Right? Write the factors now. 12 is equal to 2 into 2 into 3. 15 is equal to 5 into 3. 21 is equal to 7 into 3. Now what is HCF here? HCF is finding common, that is the number which is common in all the three. So what is the number which is common? 3 is common between all three, right? So HCF is 3. LCM. What do we do in LCM? First write what is common. 3 into. Now check if any other number is common. Now here children, what has happened is we don't have any other numbers common. We first find common in all three for LCM also, that is 3. Then we have a condition that we can also find common for 2 also. Assume that there was one more 2 here. Just assume. It is not there, but just think there is one more 2. If there was one more 2, then we can take common this also and write here. First see that common between all three. Then see that common between 2. Then write all the remaining numbers. Okay. So there is no other thing which is common. So what are the remaining numbers? 2 into 2 into 5 into 7. So when you multiply this, you get 420. That's all. HCF is 3, LCM is 420. That's the answer. So we are done with that. We'll quickly move on to the fourth one. They have given us the given relation. Usually such type of sums are asked. So where you have to find given that HCF of two numbers is given, find the LCM of two numbers. With the relation we have to find. You need not sit and do the LCM procedure there. We'll quickly finish with that. Fourth main, given that HCF of 306 and 657 is 9. So LCM of 306 and 657 we need to find out. Now just don't sit and start, your common factors or LCM method. Numbers are quite big, it will take very long time to divide, multiply also. So let A is equal to 306, B is equal to 657. We know that A into B is equal to HCF into LCM of given numbers. What is A? 306 into 657. HCF is 9 into LCM. Bring this down, linear equation method, that's all. 306 into 657 divided by 9 is equal to LCM. Start dividing this. What will you get? From 9 when you divide it. So you will get quite a big number, children, again here. You will get answer as 22338. Still simple, but you have to divide and find this. This is how we find. So till here whatever sums we had, they were basics. Now we have exactly what fundamental theorem of arithmetic tells us and gives us the information. That is what we are going to apply in the next two sums. Let's check that. Now here they have given that. Check whether 6 raised to n can end with digit 0 for any natural number n. They can also ask for 7 raised to n, 8 raised to n. Any number can be asked for raised to n. And always remember, the numbers are asked such a way that which cannot end with 0, only such numbers are asked. They will not ask you the number which can end with 0 here. Remember that one thing. So check whether, and there are certain steps what you have to actually write in this sum. Those 3 steps if you write, you are done. That sum is done. Just see the steps here. Solution part. Check whether 6 raised to n can end with 0. If, I'll explain this, 6 raised to n ends with 0, then then it must have 5 and 2 as a factor. Right? Because when it has 5 and 2 as a factor, 5 2s are 10. Anything which is expressed in the product of any number as a 5 and 2, let that be any 2 into 3 into 7 into 9 into 5 into 2. 5 into 2, what will you get? 10 as an answer. So it should have a factor of 5 and 2. Only then a number can end with 0. Remember this one thing. We are going to apply the same thing in our next exercise when we solve. Children, one more thing, if you remember, in 9th standard when we studied about rational numbers there, you had a concept telling that check whether a condition for p by q, if you remember this. What condition for q will suggest that the number is a terminating decimal? If you can remember, recall that. So we gave a condition saying that the number has to, it should either be in the form of 2 raised to m or 5 raised to m. It should be in this form, the denominator. Only then it is terminating. We always use such numbers because 2 raised to n, 5 raised to some number, if it has a factors also, it can end with 0. So this is what we are going to use in this form as well as in the next exercise form. So it should have factors as 5 and 2. Okay. This is first point, but we know that the only prime factors of 6 raised to n is, what are the factors of 6? 2 into 3 raised to n, which is equal to 2 raised to n into 3 raised to n. This is a common steps what you write. And the last step, from fundamental theorem of arithmetic, we know that definition of fundamental theorem of arithmetic is to be written here. We know that prime factorization of every composite number is unique. Therefore, 6 raised to n can never end with 0. There are several numbers, 7 raised to n, 5, any number if it comes like that, you need to only write it in this form and conclude it, right? These steps are common here. The next one, explain why the given two numbers are composite numbers. Now what are composite numbers? Composite numbers are the numbers which can be expressed as a product of its prime, right? But two or more factors if we can express it. Let's do that. Sixth one, so solution. 7 into 11 into 13 plus 13. So this is the first part of number. We can write this number as, we have a number which is common, 13 is common, 7 into 11 plus 1. So 13 into 7 into 11 is this, plus 1 is 13 again. 13 into 77 plus 1. So you have 13 into 78. Now we have 78 children here. How do we write 78? Actually prime factorize that. You can prime factorize here. So 78 can be prime factorized as 2 3s are 6. 2 3s are 6, 1 remainder, 2 9s are 3 1s are 3, 3 3s are. So this can be written into 3 into 13, that is nothing but 13 square into 2 into 3. Keep this as it is. That means I can express this number as a product of 13 into 13 into 2 into 3. How many factors? There are more than 2 factors here since it is a composite, right? Let's see the next one. You have to actually do below this. I do not have a place here, so I'll go I will just do it beside. What is the next concept asked? 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. They'll always give you such numbers that you can take something common. What I can take common? 5. 7 into 6 into, leave this 5. 4 into 3 into 2 into 1 plus 1 because 5 is there. Now multiply 7 into 6 into 4 into 3 into 2 into 1. How much do you get? 1008 plus 1. 5 into 1009. That's all our work is to do here. Now, what is it? Give the conclusion. Therefore, since the given numbers has 2 or more factors, hence they are composite. What they have asked? Hence they are composite numbers. So what did we do basically here? What numbers they gave? We just try to take something common and we express them as some product of prime factors. 2 set of numbers were given. Even here we try to express them. That means the given number, whatever number is there, that number we can express as a product of prime factors. If we can express the given number as a product of prime factors, that means those are composite numbers. That's all, right? We have some sums with different combinations here, children, again. So, and the last sum of the exercise, with that we will wind up today's session. So, let's see. We'll read the question to understand, and that question gives you an idea what type of questions are asked or the verbal statements are asked if it is a LCM based question. So another one session for this chapter. So we'll be completing real numbers. Okay. There's a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, and Ravi takes 12 minutes for the same. So they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So always when you have a question that there's a traffic signal or we are running or the bells are ringing, after what point all three will come in the same line, something like that. After what time will they meet at the same point? Such questions are always the LCM based questions, right? Find the maximum number or what we had in the previous exercise. You have some worked examples. Solve those worked examples. You will have an idea. So to find out after how many minutes will they meet, we need to find the LCM of the given time what they used to run. Please write one small statement for that. It is question number 7. So, by taking, because we need to explain why are we taking LCM here. By taking LCM of time taken in minutes, by taking LCM of the time taken in minutes, for Sonia and Ravi, we can get the actual minute after which looking again at the starting point. Yeah, that means we are taking LCM. So LCM of what number it is? 18 and 12. Now what you want to do, children? Which method? It's left to you. You want to try it with this 18. Okay. First we'll do this for this sum and then also by like that. Like this together also fine. Take prime factorization and do. That's also fine. 18. 2 nines are 3 threes are, then 3 ones are. It's again the same thing. So 9 twos are 18, 3 threes are 9. For 12, when you have 2 six are 2 threes are. So 18 is equal to 2 into 3 into 3. 12 is equal to 2 into 2 into 3. What is common? First write what is common. So we'll first write it like this. First 2 is common, then 3 is common. So LCM. First write the common. 2 and 3 are common. What is remaining? 1 more 3 is remaining, 1 more 2 is remaining. So 3 threes are 9, 9 fours are 36. Right? Let's just try here, children, once and show it to you how we do it. We start with 2. 2 nines are 18, 2 six are 12. 3 threes are 9, 3 twos are 6, right? So LCM is equal to 2 into 3. We multiply this and we multiply this into 3 into 2. LCM is 36. I wanted to show you this one method also. Therefore, get the conclusion. Therefore, they meet at starting point after 36 minutes. Right? So with this, we end this exercise. I've given you some sums for practice. Please do that. Another small exercise, another 2 exercises actually which we can club and make it one exercise. So there's one more last session left for this chapter.